capital V is inversely proportional to N. What is capital V? Hall PD. Hall PD is inversely proportional to number of free electrons per unit volume. So if N is large, for a pure conductor, Hall voltage will be less. That is why Hall voltage, Hall effect is more prominent in semiconductors. You have to now copy this.
Done, sir.
This is how we place a semiconductor. This is how we place a semiconductor to test the Hall effect. After copying this, write under it, Hall effect is more prominent. Hall effect is more prominent in semiconductors. Hall effect is more prominent in semiconductors Now look at this screen, and this is how we place the semiconductor chip. Hall effect we have discussed in detail, and I have shared some videos, animations. This is a difficult topic. Some topics we are doing as usual, the difficult chapters first. And I'm not sure what school is actually doing, because you have to follow the track also. If they have given you any syllabus for term number 1, you can share with me, so that we can if needed, we can change the plan. Otherwise mocks can be in problem. Now give a new heading, Hall probe. Hall probe is an application of Hall effect. It is one of the most sensitive instrument probe to detect and measure magnetic field strength. Magnetism is an invisible phenomena. You can feel it, you can get it, but you can't actually observe it physically. It's only an observation. So Hall probe was invented because Hall effect was there. Hall effect was creating voltage, and voltage is something which can be taken on a meter. So they thought that by using a voltmeter, we can calibrate a magnetic field. So this was the idea. Hall probe is a device used to sense and measure magnetic field strength. You have to copy this screen.
Done, sir.
Overall, Hall probe is a very sensitive instrument for a magnetic field. This is the appearance of a Hall probe. Now look at this. It has a handle and a semiconductor wafer. Hall probe. Actually, I forgot to mark here. After the heading, you have to mark it P5. This topic comes in P5. This is the simple structure. Paper 5 is basically, we did one class in the start when we started the session. I think you were there perhaps or not. I don't remember now. But we did one class for introduction. Paper 5 is actually a skill test. It's a concept of checking the skill on a paper. There is a handle and there is a semiconductor wafer. It's a small device, small component, but it is extraordinary sensitive for magnetic field. You have to copy this.
Done.
Hall probe works on the principle of Hall effect. The basic idea that Hall voltage is produced. So what we do, we track it on basis of voltage. We create a voltage from the Hall effect and we measure the voltage. This is how a Hall probe works. This is how a Hall probe works. This is Hall effect. So right under it, Hall probe works on the principle of Hall probe works on the principle of Hall effect. A Hall PD is produced. A Hall PD is produced a Hall PD is produced. A Hall PD is produced when it is placed perpendicularly in a magnetic field. A Hall PD is produced when it is placed perpendicularly in a magnetic field. In a magnetic field. Now proceed the same paragraph. Once calibrated, once calibrated, once calibrated, It can read magnetic field strength. Once calibrated, it can record magnetic field strength. So this is the idea of a Hall probe. This is the idea of a Hall probe. Now, Hall probe is very sensitive to temperature changes. So Hall probe has only one drawback. Whenever you are using a Hall probe, you have to be careful. It should not be subjected to temperature changes. Hall probe does not work accurately when temperature changes. Why? Because it's a semiconductor. On temperature change, number of electrons changes, resistance changes, voltage changes, and it is a misleading phenomena. Now, you have to write under it that Hall probe that Hall probe Hall probe does not respond accurately it does not respond accurately when temperature is changing. Now you have to copy this screen.
Answer.
Now look at this screen. This is a Hall probe sheet. It's a semiconductor chip, and we place it in a magnetic field. B stands for magnetic field, and we get a PD voltage across the terminals AB. So this is how a Hall probe works. Remember, Hall probe works on the principle of Hall effect. This is where Hall probe is working. Now we have placed it in a magnetic field. It is able to generate a voltage. Now the concept of physics is there that you will measure the voltage, but this voltage is directly proportional to B. You will measure the voltage, but it is directly proportional to B. So measuring voltage can be calibrated for magnetic field strength. Now you have to copy this screen. I'm just coming, copy this screen. After mentioning this concept, that Hall probe is a sensor. Hall probe is a sensor. So being a sensor, it has to be calibrated. Now give a side heading, calibration of a Hall probe. Calibration of Hall probe. Now, this is a concept. Hall probe must be calibrated. What is calibration? Calibration means making a numerical scale. Suppose you take out a new graph paper. Suppose you take out a new graph paper and you want to draw a graph. The first thing you have to do is to draw an x-axis and a y-axis, and then you have to number it. When you number it, when you make a numerical scale, this is called calibration. This is called calibration. Now, right under it, all probe must be calibrated before use.
Done.
Now, remember how to calibrate it. We first place it in a known magnetic field. We place Hall probe in a known magnetic field. We place Hall probe in a known magnetic field, let's say B naught. And then we place it in the target magnetic field and we measure the voltage. I repeat, we first place the Hall probe in a known magnetic field and measure the voltage V naught. Then we place the Hall probe in the target magnetic field, measure the voltage, and then apply this ratio method to calibrate Hall probe. So after writing this, right under it, place the Hall probe in place the Hall probe place the Hall probe in a known magnetic field place the Hall probe in a known magnetic field, measure the voltage, V naught, then place it in the target magnetic field, then place it in a target magnetic field and measure the voltage V.
Done.
Okay, now you have to copy this this small derivation.
Done, sir.
B is equal to target magnetic field. Look at the circuit. This is the circuit we use for calibration. You have to copy this screen.
Done, sir.
Now, give us side heading, advantages and disadvantages. Now, give us side heading, advantage and disadvantage, right under it that Hall probe is very sensitive. It can detect Hall probe is very sensitive. It can detect even a small amount of voltage, a small amount of magnetic field. Hall probe is very sensitive. It can detect a very it can detect very small magnetic field. Next line. Hall probe is small in size. The advantage of small size, you can carry it always. The main advantage of Hall probe is that it is so sensitive that it can detect even a weak magnetic field. They use it on satellites, and the Hall probe is so sensitive that it can pick the surrounding magnetic fields. So Hall probe is extraordinary sensitive, but this advantage becomes a disadvantage because when you are using it, you're not actually in an isolation. So suppose you are measuring the magnetic field of a source, but the source can't be alone. Magnets are all around us. In a room, you can find magnets like a fan, like a projector, like a television, even in your watches, clocks, everywhere. So Hall probe picks everything, and that is the problem. So now change the line and write under it. Hall probe is oversensitive. Hall probe is oversensitive is oversensitive. It picks surrounding magnetisms. It picks surrounding magnetism. Next line, right, change the line and write under it that Hall probe is very sensitive for temperature changes. Hall probe is very sensitive for temperature changes. Some common uses of Hall probe: wheel speed sensor, proximity sensors, automotive fuel level indicator, which I shared with you today also, a very good video. Now you have to copy the common uses of Hall probe.
Done, sir.
Now give a new heading, current balance.
Done.
Now look at this concept. Current balance is a method used to measure magnetic field strength, the same job which Hall probe was doing. But Hall probe has some issues. As mentioned, it is oversensitive, it's sensitive to temperature. So they thought of developing an alternate for Hall probe, and the first alternate came was current balance. Magnetic field is one of the most mysterious field in its time. So they were always looking for some device, some probe to catch the magnetic field. Current balance is a good alternate for Hall probe. So give the heading current balance and write under it. You have to copy this screen.
Done.
Now, this is the apparatus, and this is a wire which I have placed in a magnetic field. And when you allow current in the wire will experience a force whose direction can be predicted using Fleming's left-hand rule. But there will be a downward force. There will be a downward force due to the reaction. This is a concept of reaction. Now, how they managed to translate it into apparatus, they took a horseshoe magnet, they made a circuit, and a switch is presently off. Under the wire, they put a pan balance, a sensitive meter which can detect the forces. When they close the switch, current passes through the wire. Now, current will apply a force on the wire. Maybe the force is downward according to left-hand rule. When the force is downward on the meter, meter can record the force. Then we have the formula F is equal to BIL sine theta. L will come from the meter rule, I from the current, F from the digital balance, and hence we can find the value of B. This is called current balance. We arrange an apparatus, we make an apparatus of current, and we get a force on the current, and we measure the force by a pen balance. Using the derivation, we can find the value of P. This is a better version, obviously a complete version of the same apparatus. The idea is simple, that we will use a pen balance to record the force. And once we get the force, we can find the value of P. So you have to copy this screen. I'm just coming. I have to say namaz, asr namaz here. So I will be starting shortly.